And now, the last speaker of the morning is Jiangang Liu from Beijing Agricultural Information Technology Center. So he is going to talk about how to use UAV platforms in breeding context.
Hello, everyone. I'm Jiangang Liu, who comes from Nesita. It's my pleasure to make the presentation in the 4th International Plant Phenotyping Symposium. My presentation topic is about strategies for field-based phenotyping in crop breeding using UAV remote sensing platform. There are several types of field phenotyping platforms, such as fixed platform, ground vehicle platform, and UAV platform. Both fixed platform and ground vehicle platform have the advantages of high precision, multi-observation angles, large payload, and long working time. However, the cost is very high. It is necessary for developing low-cost field phenotyping platform. UAV has the advantages of flexibility, suited for complete environment and low cost. In China, the cost of its rotary UAV is about $300 to $600. It is very cheaper. Then, what can UAVs offer for the field-based phenotyping in breeding? It can quickly and non-invasively and cost-effectively characterize the spectral texture, structure, and crop growth of large numbers of plots, which can be used for retrieving phenotypic data such as leaf area index, crop canopy cover, canopy temperature, and so on. Then, what are the challenges for the field-based phenotyping by UAV remote sensing platform in crop breeding? As there are a large number of breeding materials, and the crop growth stage of breeding materials may be different when we measure at the same time. So the retrieval models of remote sensing for analyzing phenotypic traits is different from the previous research. So we need to develop new methods and models for retrieving the phenotypic data in crop breeding. And UAV remote sensing platform can quickly acquire a large number of remote sensing data. The rapid method for the data processing is challenging. And finally, even many phenotypic traits have been analyzed with different field phenotyping platforms. However, there is still lack of strategies for direct varieties selection. Today, a case study about strategies for UAV-based hyperspectral for field-based phenotyping in soybean breeding will be introduced. Why we use hyperspectral imager for the field-based phenotyping? The first picture shows the spectral curve of soybean. The leaf pigment is sensitive to the spectrum in the visible bands, while the vigor and crop growth, such as biomass and leaf area index, are sensitive to the spectrum in the near-infrared bands, and leaf water content is sensitive to the spectrum in the far-infrared bands. The right picture showed about the spectrum of different breeding materials. We can find that there is a significant difference of spectrum in the near-infrared bands. In our study, its rotary UAV deployed with hyper-spectral imager was used for the phenotyping inbreeding. Biomass is important to indicate photosynthesis and respiration and can be used to estimate soybean yield. However, the traditional method for biomass estimation is by manual sampling, which is destructive and time-consuming. UAV deployed with hyperspectral provides a new way for quick biomass monitoring. However, when we get this remote sensing data, how to use with it? As an agronomist, I think the strategies should be simple and easy to use. There are dozens of vegetation indices can be built with the spectrum in different bands. Then, how do we use them to build the retrieval models for the biomass monitoring? The GRAAIC-PLSR method was adopted in our study. Firstly, non-vegetation indices, including the spectrum in different bands, were built. Then the gray correlation analysis was conducted to determine the relationship between vegetation index and biomass. The vegetation indices was built with the sensitive bands for each one, and we can see that the best accuracy can be obtained with a single vegetation index is by RVI. As we know, the accuracy of biomass estimation can be increased with the combination of vegetation indices. So we want to combine these vegetation indices to estimate biomass. However, there are not vegetation indices. If we put all into the model, it is too complicated. So we want to determine a method that can have less vegetation indices for model building. In order to solve this problem, the archaic information criterion was adopted to determine the optimal number of variables for model building based on the minimum AIC value. The AIC is a measure of relative quality of statistics models for a given set of data. The variables can be added only if the increased variable can reduce the AIC value. In our study, the optimal number for model building is 4. So the first 4 vegetation indices were used to build soybean biomass estimation model. When we estimate biomass, we found that there is a strong relationship between biomass and plant height. As we know, the plant height can be easily estimated by the digital service model generated from all-through images acquired by UAV platform. So the vegetation indices combined plant height were used for the soybean biomass estimation. As the relationship between biomass and spectral characteristics is different in different growth stage. So the segmentation modeling method was used for building biomass estimation model. The model for the biomass estimation in flowering and podding stage is the first one, and the model for the biomass estimation in the growth stage of filling and maturity is the second one. Both models showed a good accuracy for biomass estimation. As we know, yield is the core of crop breeding, and which can be directly used for variety selection. However, there are maybe exceed 20,000 breeding plots in commercial breeding base. It's hard work if we harvested all the breeding materials, so the workload can be decreased if we can predict soybean yield model. The yield prediction by hyperspectral can be based on 4 types of data. The first one is original spectrum. The second is first derivative spectrum, and the second one is vegetation indices, and the fourth one is fusion of plant height and vegetation indices. The spectrum handled with the first derivative can increase the accuracy of yield prediction compared with the spectrum. The best accuracy of yield prediction can be obtained with the spectra in the filling stage of soybean. In order to understand the vegetation indices, in order to understand the relationship between vegetation indices and yield, the regression analysis was conducted. We can see that the sensitivity of NDVI is higher than RVI in the pod filling stage for yield prediction in soybean breeding. Then, the impact of combination of NDVI of multi-stages were assessed. We can find that the combination of NDVI in the growth stage of flowering stage, podding stage, and podding filling stage can have a highest accuracy with the coefficient of determination of 0.63. Okay, the first 3 methods have been analyzed. The last method is about the combination of plant height and vegetation indices for yield prediction. Three statistical methods were adopted for the yield prediction. We can find that the multi-linear regression method showed the best accuracy with the coefficient of determination and NRMSE of 0.83 and 6.61 respectively, while the stepwise linear regression method showed the worst accuracy. Okay, the yield prediction model have been analyzed. Then how we did these models to reduce the workload of breeders? What we think is to eliminate the breeding materials with yield lower than the check varieties, and only harvest the varieties with yield higher than the check varieties. We can find that the classification ratio by different statistical methods to select the target varieties can exceed 97%. So the yield prediction model provides a new way for the variety selection. let's say what we have done for based UAV platform in breeding. We can measure crop height, leaf color, chlorophyll, loading area, and so on. Now, and what we are working on. We are working on increasing the precision and replication of retrieving models, and do some work about the fusion of spectrum and thermal data to predict yield, and determine the strategies for phenotyping of different crops. In the recent years, we have done more than 500 flights and covered farmland area more than 200 hectares, and the data size reached 2 TB. The crop we studied include soybean, wheat, and maize. The cooperating institutions are listed, including Nanjing Agricultural University, Northwest A&F University, CAAS, and so on. Okay, let's make a summary. First, UAV remote sensing technology is a good supplement for airborne satellite remote sensing and ground observations. Second one, UAV remote sensing has a huge potential values for large-scale crop breeding to improve breeding efficiency. Thirdly, it is also important that we should speed up data analysis and keep high estimation accuracy. Developing real-time acquirement and processing system is a future trend. Fourth, the GRAAIC-PLSR method provided a new way for biomass monitoring in soybean breeding using UAV remote sensing platform, and the PLSR method for best accuracy for screening target varieties. Finally, determine the optimal methods, parameters, and growth stages is very important for the crop growth phenotyping in breeding. It is only a preliminary study by our team, but we believe that there are more work will come. Thanks the partners of different institutions. Okay, thanks for your attention. Yeah, okay. Okay.
Planning to have a show here, but just a question. Thank you for emphasizing on the need for speeding up the data analysis, because you create a lot of data there. That's my comment. And then two quick questions. One is, after all these years of working that you mentioned, you have only 2 terabytes of data of hyperspectral images. That's quite.
This is just a case study.
Yeah, but you said you've done years of work and hectares, but that's I think that's wrong information anyway. That's one. And the second one is, you mentioned you showed a real-time spectral camera.
Yeah.
What do you mean by real-time spectral camera?
Okay.
What do you mean by that? What is a real-time spectral camera? Real-time data analysis, real-time providing the graphs real-time and into your desk?
Okay, I'll answer your question. For the first question, we have done several years of work on field-based phenotyping in crop breeding using UAV platform. Today, I showed just a case study about hyperspectral for biomass monitoring and yield prediction. I think if you are interested in our work, maybe we can talk more later. Yeah. For the second one, the real-time acquirement and processing system of UAV, I mean the real-time data analysis. Yeah, we can develop some softwares automatically process the data we acquired and then to. Yeah, but now it is hard to achieve now. Maybe in the future. Yeah. Okay. Thank you.
Okay, thank you very much.